Hello and good evening, everyone. Today we are going to start our session 33 of Python and Data Analytics Internship Program, October 2025. Today, the topic that we are going to cover is data transformation and feature engineering. So we will go through these two terms, that is data transformation, as its name suggests that we are transforming data from one way or one shape to another. And then we will do the feature engineering, that is a technique that we use during data analysis in case we don't have our data with us or the raw data is not according to our needs. So we will see how we can make the data that we have with us so in a so that we can utilize it according to our needs. Okay, so let's start. So why today's session matters? Let's see upon the key highlights why we are learning about data transformation and feature engineering. So in real world projects, most of the time we what we do is that we invest or spend before modeling. Okay, most time is spent before modeling in real world projects. I will let you know why what statement conveys to us. Raw data is rarely ready for direct use. Model performance depends heavily on data quality. So the data that we have with us, I have told you many times, it is not the data that we are going to use in our data analysis as it is. Okay, just give me a second. So the more the data that we have with us is basically not ready to use. It is in a raw format, that is it is in a format that is not easily to understand or analyze by the machine itself. Like when a car is being produced at the factory, so car is not getting produced on the fly, like okay, you have put the materials and it has come out from the machine as a ready-made car. No, that is not the way. A proper planning is done before that. Proper aerodynamics are utilized. Proper engineering, mechanical engineering techniques are analyzed. Engine capabilities are analyzed. How much the turbo force the engine can generate, according to that the model and the weight upon that particular vehicle, that is car, is analyzed. After all these analysis, after all this research has been completed, then that the raw material is brought, that raw material is purified to a certain limit, or a purified raw material is bought, and then after that they are transformed into different parts, and those different parts are combined together in order to basically produce a full-fledged car. So lots of work is being done before even assembling the parts or producing the parts, that is planning, analysis, all the engineering techniques, etc. Okay, similar thing happens with our data also. So when the data is with us, it is not what we want, it is not according to the needs that we have. We have to transform that data according to our needs so that we can utilize it in order to derive the desired end results of the customer. Okay, so data, a client can give you data in any form. Okay, he is not basically what we can say that he is not responsible for to provide you the complete data. That is, no missing value should be there. He will not provide you a ready to use data. You have to make that data ready in order to use it. So most of the time is spent before modeling. Like we spend most of the time basically on analyzing, planning the things, etc. That we have discussed about 6 steps in session 31. Okay. Raw data is rarely ready to use for direct use. It happens very, very rare that you can directly consume the data. Lots of work you have to do in order to utilize that data. Model performance depends heavily on the data quality. The higher the quality of your data is, the higher the accuracy of the model is will be that you are going to produce. Okay, so what we do, we want to increase as much as possible so that our model's prediction accuracy increases according to our data quality. Okay, so this is what happens in real world projects. So in this session, you will learn how to convert raw data into usable formats. We have seen many techniques right now, but today we are going to see some of the advanced and highly used techniques in data analytics. Create meaningful features from the existing data. Sometimes there are the data that you have may not contain all the features or all the columns that you are going to utilize in your data analytics. So what you will do, you will combine one or two columns in order to generate a whole new column which you will be going to utilize in data analytics. Okay, so we will see how to improve model accuracy and stability that we have discussed. Understand why pre-processing is critical. This thing I am explaining to you from last 2-3 sessions. Okay, pre-processing the data is a very critical part. If you have performed this part, that is pre-processing your data in order to make your raw data into a ready to use data, okay, this steps basically marks your ending result. Okay, if you have completed this step very in a very efficient way, okay, the data quality you have increased, okay, and in that you have transformed that data into a very useful data, then your end results are going to be very accurate and very satisfying. And if you have not performed this pre-processing step very carefully, then it might lead to inaccurate results at the end. Okay, even simple models perform well with good features. Remember this thing, your model need not to be a complex model in order to perform very good. But what important is that if your data quality is very high, your pre-processing steps are performed very efficiently, then even a simple model will give you good results. So what is data transformation? Data transformation means changing data into a format that is easier for analysis and models to understand. So we have the raw data with us. We will apply some techniques on that raw data in order to transform it into a format that is easier for analysis and models to understand. Remember that model only understand machine language, numbers. Okay, they only understand numbers that in the form of 0 and 1s. Okay, they do not understand your English text, that is A, B, C, D. That in order to get your model understand those English text, that is high level language, you need to convert those English alphabets into numerical values so that the machine can understand it. Okay, so it helps in making values comparable. We will see in the upcoming slides. Reduce biases caused by scale differences, improving learning efficiency. So I will explain you in a brief these three lines. Making values comparable. Okay, you can compare only those things that are close to each other. If someone is having 1 lakh rupees, you cannot compare a person having 1 lakh rupees to a person having 1000 rupees in his pocket. It is basically way beyond that comparison. And what happens is that the higher the number, okay, so when the number is higher, suppose you have five people, one is having 1000 rupees, one is having 2000 rupees, one is having 3000, one is having 4000, and the fifth person is having 1 lakh rupees. So when you prepare a model so what will model will think is that 1 lakh is way much greater than 1000, 2000, 3000, 4000. So it will make decisions in the favor of a person having 1 lakh rupees because that number is higher. So model thinks that, okay, this is the higher amount. What prediction is generally? You are having a set of probabilities, set of numbers. The higher the number is, the model thinks that the more accurate it is. Okay, like if you have 100, okay, from 100 you are having 96, and then you having number 5. So model will think that 96 is a greater number than 5. So 96 may be the correct result. It basically generates a biasness. It always favors the person having the larger number, that is larger amount of rupees. So it, you can say that it is a rule of a rich. The richer the person, the model will favor him that. But we want our model that it should not generate bias results. So what we will do is that we will compress that 1000 and those 1000, 2000, 3000, 4000 and 1 lakh rupees around a centric value that is 0. Okay, like we will compress those number according to 0, in near to 0, so that they can be comparable. Once, so model will think that, okay, one person having 1 lakh rupees is also same as person having 1000 to 1000 and 4000 rupees. They both all the five are the person only. Okay, so then model will start generating results fairly. It is a bit confusing, but I will tell you later if you have not understood it. But it is a complex concept that you have to remember. So we have talked about reducing bias, improving learning efficiency, and etc. Common transformation includes scaling and normalization, encoding categorical variables, handling skewed data, transforming dates and text. We will see it in the next slides so that you can understand it. If I started explaining you here, so you will get confused. Okay, let's see first about scaling and normalizing. Just give me a second. Okay, so now what scaling basically means: machine learning models perform better when numerical features are on similar scales. I will give you an example of it right now, not the coding one, just an example so that you can understand it way better. Why scaling is needed? Some features may dominate others due to large values that I have told you right now. Distance-based models are sensitive to scale. Common techniques are min-max scaling, scales value between 0 and 1. Standardization, mean equal to 0 and standard deviation equal to 1. Basically, we want to concentrate all those values around 0. Okay. So if I write a example to explain you, is like, consider that there is age, and age is between 22 to 50. Okay, after that we have income, and income's value are between suppose 25,000 and 85. Okay, 85,000. So now here what is happening is that you can see income values are much larger as compared to age variable values. Okay. So model thinks that income is more important just because numbers are bigger. That is 25,000 and 85,000. We are dealing here under 100 and we are dealing here above 10,000. Okay. So 100 and 10,000 are very, very farther apart. So whenever model will predict something in the future according to our needs, so what model will think, okay, 25,000 is greater than, यानी जिसका जितना ज्यादा पैसा उसकी उतनी ज्यादा वैल्यू. Okay. Model does not know that age is regarding a person's age, income is regarding the physical assets that the person is having. He is not emotional or consciously aware as you are. Okay, money is different, age is different. He doesn't know these things. Model only knows numbers and their context. Like age is a variable having numbers between 22 to 50. He does not even care. Age is different thing or income is different thing. What he's seeing is that he's seeing only the values of number. So model is seeing that okay, 22 is way much smaller than 25,000. So model will think income is more important just because its numbers are bigger. So this is a problem in data analytics. So what is the solution to this? We need scaling here. So scaling brings all the numbers to a similar range. Means if we are having 22 or even 25,000 or even 25 lakh, they will come together in a way so that model gives equal priority to equal priority to all the variables. Okay, so scaling prevents larger numbers from dominating smaller numbers. It is not like rich peoples are dominating the poor here. So we will make everyone average. No one will be poor, no one will be rich. So model will then uh, produce the results fairly without any type of biasness. Okay. So this is what scaling means. And what standard scaler does in simple words, if I can say, is that it centers data around the number 0. What happens as a result of this is that values, it gives values comparable. You, okay. So like it will reduce, give me a second. Okay, so this is how the things are being done. So what scaling do is that it will compress these values near to 0, like 0 0.1, some will be 0 0.7, some will be 0 0.4. Okay, you don't need to worry about the maths behind it. You only need to remember that we have to scale down the values so that they can become comparable with each other. Okay, and how to do this is basically, uh, just give me a uh, where is my PPT? Through this piece of code, that scalar, you create a variable scalar, then you use this function that is standard scalar. It will make those values comparable by itself, you don't need to basically bother about what is happening behind this function. You don't need to bother about the maths. You only need to remember that we have to make values comparable using this thing. So if we can see this through the example, like today I might not be able to give you each and every example because there are very important concepts that you need to clear as fundamentally first. Import pandas SPD. Then we will be importing NumPy as NP. NumPy is used to deal with arrays from. This is a module that you have to import sklearn. Okay, there these features come on its comes up on its own. I think we have to import this first. I have not installed the dependencies first, so it might throw an error. Yeah. So this line you have to basically use it here. Just give me a second. I will quickly activate my VNV, then we will import it. Okay, so we are using different folder today. We haven't created the VNV environment. So we can directly install pip install. Then you have to use this scikit-learn. Okay, so you have to do this installation of scikit-learn in order to use sklearn pre-processing and then standard scalar function. Okay, it will take some time. Let's uh, give it some time and to completely learn it. Meanwhile, we will move to our next topic. Then we will come to that example again. So now we have to see about encoding categorical variables. Now in the previous slide we have seen we will make values comparable using standard scalar function so that they comes near to zero value, so that we model will not generate biasness according to the uh, number, like if someone is having smaller number and someone is having greater number. Similarly, encoding categorical variables is also as much important as scaling those variables. So what encoding does is that encoding machine learning models cannot work with text. I have told you this many times that machine only understand the numerical values, not the high level language that we use in our daily language. Like high level language, consider it as English or any medium of communication. Okay, so like you have gender, male and female. So machine does not know what is male, what is female, what are the features of male, what are the features of female. He is completely unaware of it. But you have to convert that male, that is basically you have to convert that text into numbers. And the process of converting that text, that is, for example, male word into numbers, is called as encoding. In simple words, if I can tell you. Okay. So categorical values must be converted into numbers, as I have told you. Common encoding methods are label encoding, converts categorical categories into numbers. One hot encoding creates separate columns for each category. So these are some techniques. Like in one hot coding, what happens is that we can make machine understand, okay, male is equal to 1, female is equal to 0. So whenever a male word arrives, machine will convert that to 1. Whenever a female words arrive, machine will convert it to 0. So uh, if we can say in one line is that encoding teaches machines how to read categories. Okay, this gender comes under categories. Okay, he's a yeah, so the person is a male or the person is a female. So we will make machine understand those categories by converting that piece of text into numbers, and this process is called encoding categorical variables. Let's see if our installation is being completed or not. So okay, we have installed it, and now we will not get the error. Okay, now as you can see, we are able to successfully import sklearn pre-processing for you to basically use it in our session. So remember, you have to run this line where it is. This pip installed scikit-learn. Okay. So after this is being done, then we will use df equal to pd.read csv underscore csv. Then we will name the file that we want to use session 33. Okay. And after this, let's see how the data looks. df.head. Okay, this is our data that we have. Customer ID, gender, male, female, female, male, age, monthly income, purchase amount, quantity, and purchase date, on which date they have purchased that particular item. Okay, so after the first step is done, then I have told you that you have to see your info, your data, understand it using df.info. Okay, how the things are, like this is in, this is object. Okay, so this is how you will understand your data. Then you will use df.describe. I'm not going through all those steps. So we will directly come to our logic part, that is we will use scalar variable, then we will use standard standard. Okay, standard scalar. I don't know why this is not. We will use it here. Scalar, scalar equal to standard scalar. Okay, now we have bring this function that we have seen, standard scalar, that we use in order to scale our values so that they become comparable. Then what we will do, we want to scale our income column, because our income is having larger values like 25,000, 48,000. Yeah. So we will scale it down to near to 0. Okay, so df, then we will use our monthly income scale. Let's use income scale equal to scalar dot fit underscore transform df. Then we will use monthly income. Then we will scale down our purchase column also near to zero value, df purchase scaled equal to scalar dot fit transform df, then we will use purchase amount. After this we will do df MT monthly income, comma, income scale. Let's see if we are getting any error here. Okay, so we are not getting any error. Now you can see that we have used income scaled is our new variable under which our scaled values will be stored for income column. Okay, I am audible, right? Okay. So income scaled is our new column under which our new scaled values will be stored, and we are scaling the column monthly income, and for that we are using scalar, that is this we have created for this function. Then scalar dot fit transform is a function that is used to transform. You need not to worry about the math behind it. You have to simply use it by understanding it what it does. So similarly, we have done with the purchase scale column. We are not displaying it here, but if you want to see that also, you can use df purchased amount, comma, then purchase scale, then you can use dot head, then you will get the detail of that also. So we are seeing about income scale, but you have to scale down all the columns. You have to scale down all the in columns in so that they become comparable. It is not the way that you will only scale down monthly income and you will not scale down purchased amount. Okay, you have to apply the logic on all the columns so that they become comparable. So what the this function has done is that it has scaled down this 25,000 value to minus 1.15. It is very near to zero. Then next value is 0.02, negative, positive. You need not to worry about it. It's only for the machine. It will understand on its own. Okay. So it is 0.8, negative 0.8, but it is near to zero. It is 1, very near to zero. Now you can see how much further away 70,000 is from zero. But how much near is 1.05 to zero? It's very, very near. Okay. 62,000 is 0.66. So how these values are coming, you don't need to worry about it. You have to simply remember this logic. If you want to make columns comparable, then you have to scale down those values so that your machine model will not get biased with the values that is having larger values. Okay, like 22 and 22,000 are very, very different. 22 is very, very much smaller as compared to 22,000. So you cannot do a comparison there. The model will always prefer the larger number. But if you scale down to an environment where all the numbers value equally, so it will not consider, okay, this 20,000 is larger. Although this the hidden meaning behind this is 25,000 only. Okay, but model will not see it now as 25,000. It will see it as 1.1. Advanced concepts that are very, very helpful for us during this type of thing. And similarly, you can see for encoding part. If we see an encoding example also, we will see it in very, very quickly. PD dot, then get dummies, then df, comma, what we have to use, I think columns equal to the column that you want to use is gender. Okay, then comma, then drop first equal to true. Okay, then df dot n coded, sorry, df dot encoding is the variable that is storing the values. We will print it using it. Now you can see that where is our older column of gender. Okay, so it is getting by gender male. We have to see the above table, like earlier gender male, then is female, then is female. Now let's see what we are getting here. Gender true for male, false for female. It do not consider the textual meaning of true and false, that okay, this is right, this is wrong. No, it is not happening that way. Every male is being represented by true, every female is being represented by false. You can say that okay, true true is a high level language, how machine will understand. It is for your understanding. Behind this text true, machine is considering as 1, false is being considered as 0. Okay, that all things are happening behind the scene. So now income scaled, purchase scaled, and gender male. We have made 3 columns, machine understandable columns and comparable columns. Okay, these are categorical values, these are numerical values. Remember this part. That's why I have told you to analyze first the type of columns. That gender is an object that comes under categories, and age and monthly income and purchase amount are int, that are numerical values. Okay, so this is how encoding is being done here. Okay. Now let's move to our next slide. We have a lot of content to cover today. Now we will see about handling skewed data. Okay. Feature engineering. Feature engineering. Okay. So skewed data is a data that is basically spread, okay, on a different scale. You can understand it like that. Earlier we were doing okay, let's understand the textual meaning first. Handling skewed data and outliers. Skewed data occurs when values are not evenly distributed. Some values will be 1, some will be 1000, but in the same column, not in the different columns. Okay, remember this thing. Only that is what I was saying, that they are not evenly distributed. Can negatively affect the model predictions. Common transformations are log transformation, square root transformation. Outliers, extremely high or low values, can distort averages and models. Outliers should be detected carefully, transformed, kept, or removed. Okay, so I will explain you this by giving some example. This log transformation is a completely different topic. Okay. So I will explain you log transformation with it only, so that you will be able to understand what skewed values are. Okay. Suppose we have an income variable like we have having earlier. Okay. Now we have values in it like 25K. Then we have values like 30K. Then we have values like 80K. It means basically 25,000, 30,000, and 80,000. So you can see it here that 25,000 and 30,000 are okay. They are near to each other, but this 80,000 is very further apart. So when you will try to calculate the average, this 80,000 will pull the average towards itself, because if you combine 25,000 and 30,000, they will account to only 55,000, not even close to 80,000. 80,000 is very, very big as compared to 25,000 and 30,000. So what it will do, it will pull the average towards itself. So it will affect the average in some or the other way due to its skewness. Skewness is basically the values are unevenly distributed. So we will apply log transformation here. What log does is that it reduces the extreme impact and smoothens the data. Means log transformation reduces the effect of very large values over the average or other mathematical transformations. Okay, the impact that this 80,000 is having on 25,000 and 30,000 is being reduced, so that we will get the actual average, not the biased average. Okay, in that we use feature selection. Okay. So what I was telling you, like one value pulls, the bigger value pulls the average towards itself. So log transformation compresses values and spread small ones. Like this 25,000 will be converted to something like 10.12 or 10.13 or 10 point or 11 point or 15 point, means some values. I will give you example like, okay, suppose this is converting to 10 point something, this is converting to 10.5, then this is suppose 25 is 10.1, it is 10.5, then 80 might be 11 or 11.5. Now they are being compressed to each other, near to each other. How they are being compressed? Again, it's not your worry should not be about this. You should only see it as, okay, we will apply log transformation here and the values will get compressed to basically comparable values, like you were doing in here na. You were comparing the values of monthly income and purchase amount, but they are very further apart, like 25,000 22,000 is a very huge difference. Here you were doing between the columns, now you are doing inside the column the same thing. Okay, so that their skewness get reduced and the average should not get biased towards the larger value. Okay. Okay, so it is basically like scaling only, but inside the column. Let's remove this. Now, this is very main topic also. Feature engineering. What is feature engineering? Feature engineering means creating new meaningful variables from existing data. Now, suppose you want to derive an insight of a column that is even not present in your data. Okay, for example, as you can see in the data, we have purchased amount, how much amount is getting spent on one item and how much quantity we are buying it, like 2 3 4 5 6. Okay, but you don't have the total amount spent. Now in order to calculate the total amount, suppose you are spending 2,000 per item and you have brought two items, so it will be 2,000 into 2, then it will lead you 4,000. Okay, 4,000 is the total amount that you have spent and the 4,000 is the total amount that the company has received from the customer, not the 2,000. So you have to, suppose you have to generate some results using the total sales or the total amount spent. You have to generate some insights using that, but your data doesn't have those things. So there you will apply feature engineering. You will create a new column. Okay, create a new smarter column from this existing data that will take price and quantity, like two other columns. We will multiply the values of price into quantity, then we will put that new calculated value in the new column that we can call by any name like total amount spent. Okay, your total spending. So you will put that value in that column. Originally, this column was not present in your data, but you have created this column using the other two columns that were present in your data, that is purchased amount column and quantity column. As we have seen, sorry, I got disconnected due to network issue. Okay. Okay, now suppose you, as you can see in the data, that you have a date column here, but this 2024 first month of date and 5th of January 2024, this machine cannot understand. You need to break it down into month and year so that machine is able to understand it. Dates are useful only after we break them into parts, not as an aggregated values. Okay, so all these things comes under feature engineering. Binary features are there, yes or no flags, like this customer is of high value, true, this customer is of low value. Okay, these things will be made. So feature engineering is that creating new data, new columns using the already present columns in your data. Okay, it is very powerful, easy for the models, easy to interpret, and very common in real projects. So this is what feature engineering is. Now there are some examples of feature engineering here. Like you can see, date-based features you will store in under, you will create a new column here. You will create a new column here, then you will put the year from that piece of text. You will extract the year, then you will put it here. You will put the month there. Okay, these are date-based features. These are interactive. If you divide the income to by the family size, what it will give is that, okay, how much income per family it is having. Okay, like total income is itne, or there are 5 families, then divide total income by 5, then it will give you, okay, one family is having approximately this much income. Binary flags, like is it weekend day, Saturday Sunday? If Saturday Sunday is, then you will put true, false. Okay, yeah, it is weekend. So these are some feature engineering examples. If you want, we can see a live coding example also. Okay, let's see quickly the live coding example of how to basically generate a new column, like df dot encoding. We will use it here, like total purchase value equal to df encoded purchase amount, will multiply it by df encoded quantity. Now it is done. Then you can see that value by printing it like df encoded total per the chain coded. D will come here, spelling mistake. Now you can see that here total purchase value is being calculated by multiplying the quantity. 2000 into 1 is equal to 2000 only. Then we have 4500 into 2, it will give us 9000. Okay, so now you can see it here that total purchase value column is being created by multiplying the values of purchase amount into quantity. So this is what we are calling feature engineering. Similarly, you can also transform the date here like by using the code df dot encoded. Then you will use purchase date equal to pd dot to date time. You will use this function. Then df encoded, then you will use purchase date column that we have with us, purchased date. Okay, now you will use df encoded. Then we will be modifying this purchased month, purchase month, that will be equal to df underscore encoded purchase date, and from here we are extracting tt dot month. Okay, M1 T1. Similarly, you can extract the year also by using this line of code only, like Control plus C, enter, Control plus V. Only thing you need to change it here is like year, and your purchase date will remain same, and you will change it to year. We will run it. Okay, everything is running fine. So these things are created. Now we will basically print this value by using this line. Let's see how these columns are being created with total value. Let's use df dot encoded this. Now you can see that we have many new columns with us: gender, male, total purchase value, purchase month, that is first month, second month, third month, purchase year 24, 2024, 2024, 2024. Okay. So these are the columns that we have created on our own that were not earlier present, that I am highlighting. These columns like income scale, purchase scale, gender, male, total purchase value, purchase month, and purchase year. We have extracted those data using this code, and now this data is very good to utilize in our data analytics. This is how feature engineering and data transformation works in order to enhance your data so that you can utilize it with your data analytics. So feature selection, not all features are useful. Remember this thing, I have told you many times. Too many features can increase complexity, reduce model performance, cause overfitting. Basic feature selection methods are correlation analysis, removing constant or duplicate features, okay, and domain knowledge. So goal is our simple models with stronger signals. We will utilize what we have in the best possible manner by utilizing these techniques of data transformation and feature engineering. So your assignment would be: use a data set of your choice, scale at least one numerical column, encode one categorical column, create two new engineered features that, as you have seen in feature engineering, explain why each feature is useful. Okay. Then for any help and support, contact